Okay, so continue where we left off yesterday. We were talking about transformations. Yesterday we talked about vertical, what were we at? We talked about vertical stretch and shrink, right? So today we're going to start off with vertical shifts, translations. So when we look right here, we have y equals the square root of x plus 2. So this plus 2, that's the change from our parent function, right? That's what changed. That's our d variable for translations. So if d equals 2, that means that that's our up and down motion, right? So we know this is a vertical translation up. Because d equals positive 2. Versus if you look here, example D, the change from our parent function is minus 3. So d equals negative 3. And therefore, this is a vertical translation down. Okay, we're going to look at the graphs of each one of these and compare their domain and range to the original function, okay, to our parent function. So if you have your calculator out, please follow along. If not, please grab a calculator. I'm going to start a new document. No, I don't want to save. Okay, when you're comparing transformations, you always want to start with your parent function. So my parent function is just square root of x, right? So this is going to stay on the graph the entire time. Nothing is going to change from here. So I'm going to hit tab and I'm going to put in the first one, which was square root of x plus 2. So now this has been transformed. So I'm going to describe the domain and range of the transformation. So what's the domain and range of this graph? What's the domain? Where does it start? Starts where? Starts at 0, Ms. Jones. Oh, awesome. The domain starts at 0 and it continues to infinity. Okay, the range starts where? At 2. The range starts at 2 and continues to infinity. And in terms of intercepts, I only have a y-intercept, right? And my y-intercept is at 2, 0, 2. Do we all see that? All right, so those are the attributes of this function. That's what we're going to write down. So we have our domain starts at 0 and continues to infinity. So x is greater than or equal to 0. Our range started at 2 and continues to infinity. So x is greater than or equal to 2. And our intercept was only at 0, 2. How do we feel about that? Doable? All right, so we're gonna do the same thing. We're gonna analyze minus 3. So I'm gonna go back. You can, if you're using a handheld, there's a couple ways. You can double click on that or hit tab and it'll still take you there. But I'm gonna take the plus, turn it to a minus. And so now here's my function. So for this function, what's its domain? 0 to infinity, right? Starts at 0, continues to infinity. What is its range? Negative 3 to infinity, right? Because now my lowest y value is negative 3. What are its intercepts? 0, negative 3, and 9. Okay, if you're wanting to be quick at counting, if you hit menu 5, 1, click on the graph you want. So I want this graph. You can trace and it'll tell you. If you're like, I don't know where my 0 is, you can trace it and it'll tell you where your 0 is. Menu 5, 1. All right, so that's us. That's analyzing. That's all analyzing is. How do we feel about analyzing? Great. Is it doable? All right, so from here, our domain is unchanged. So it's still x is greater than or equal to 0. The range started now at negative 3 and went to infinity. That is a horrible y, by the way. And our y is greater than or equal to negative 3. and our intercepts are at 0, -3, and 9, 0. And that's what you are hopefully being able to do. Describe the transformation and analyze the graph. Describe the transformations and analyze the graphs. How do we feel so far? All right, so we've done our verticals. Now we're going to move into horizontal. Okay. So we have our horizontal. On your paper, it looks like the bar stops, but it should go all the way across. So it should say the square root all the way across x -3, x + 2. Okay, it is all underneath the square root. All right, so we're inside of the square root, which means that this is our C variable for transformation. And our C variable for transformation, we must remember that x's are what? Liars. So it looks like a -3, but it's actually a +3. So C equals +3. Because C equals +3, that means we're going horizontal translation to the right. So it's a horizontal translation to the right. All right. Over here, we have a +2. And again, our x's are, so it's not a +2, it's actually a -2. So it's a horizontal translation to the left. So when it's asking you to describe your transformations, this is what it's asking you to do. How do you feel about describing horizontal translations? Easy enough? All right, now we're going to analyze the graph. So we're going to analyze their domain, their range, and their intercept, okay? Because we're horizontally moving, which one is going to change, our domain or our range? Our domain, because that's our horizontal, right? Our x values are changing. So let's go look at that. So again, I'm going to double click here because I want to change my x -3. And now it's going to be under the square root x + 2. Right? Is that what I had? Okay. And what we write about our transformation? Did it go to the left too? Yes. Now we're going to analyze its intercepts. Okay. So I'm in its domain and range. So my domain now starts where? -2. Do we all see that? So it starts at -2 and continues to grow to infinity, right? My range was my range. Did my range change? No. My lowest y value is still at 0. Agree? All right. Now next, our intercepts. What is my x-intercept? -2, 0, right? My y-intercept is an approximate value. And so we can look at the decimal value, but we're also going to write the exact value. Does that make sense? So our decimal value is travel, boom, 1 and 41/100ths. And it literally tells you that's your y-intercept. It's kind of foolproof. All right, so let's list out the things we learned here. So we have our domain. Our domain now starts at, oh, it was -3. Dadgummit. Okay, I'll write it on the other side. I put in the wrong one first. You never saw that. Domain over this side starts at -2. So therefore, x is greater than or equal to -2. Our range was unchanged, so y is still greater than or equal to 0. Our intercepts are different, right? So our intercepts, we have obviously -2, 0. The other one was an approximation at 0 and 1 and 41/100ths. The real one, to get your exact value, all you're doing is plugging in 0. So to get your exact value, you would plug in 0 + 2. And what is 0 + 2? 2. So this equals 0, the square root of 2. Okay. On your Savas, if it asks for exact, it's going to want you to put the radical. If it asks for approximate, then you would put the 1 and 41. Okay, so I'm going to pause for a moment and I want you to find the domain, range, and intercepts for y equals the square root of x minus 3. All right. All right, let's see how we did. So for the square root of x minus 3, when I go to my graph, I'm going to change this bad boy from +3 to +2 to -3. Hit enter. And did it go to the right like we said? Yes. And for this one, do I have a y-intercept? No, I never crossed the y-axis. So therefore I have no y-intercept, but I do have a special x-intercept right here. And that's at 3, 0. So this is where my domain begins. Was my range changed? Did my range change? No. So the domain now started at 3 and went to infinity. So x had to be greater than or equal to 3. My range did not change. And my intercept is only at 3, 0. No, it's not there. You only put it where it's at. All right, how do we feel about horizontal translations? Doable? Yes? All right, so now we're going to move into horizontal shrink and stretch. Okay, so here, that means we're working with our b variable. So in this one, b equals 5. Okay, remember our x's are liars. So we would think that this would be a stretch, but it's the opposite. It's actually a shrink. That's because it's greater than 1. So this is greater than 1. So this is actually a horizontal shrink. I hope I spelled that right. I think so. All right. With that same token on this side, our b, well, the b here, the absolute value of our b is 1/2. And 1/2 is less than 1. And less than 1 is actually a stretch. X's have to be difficult, I tell you. Okay. Now, this one also has a negative. So paying attention to the negative means that you have, so not only did it horizontally stretch, but it also did what? It reflected, right? So we stretched and we reflect. It's always the opposite. So if the negative is with x, then it's going to reflect over the y. If the negative is with the y, it's going to reflect over the x. So in this case, our negative is with the x, so it's a reflection over the opposite, over the y. All right, so those are our transformations. Now we're going to graph and analyze the domain, range, and intercepts. Cool? So we have, double tap, the square root of 5x, right? All right, so it's shrink, which just means that you went in. So it's shrink. And did our intercept change? No. It's just zeros are still there, right? Did our intercepts change? No. Did our domain and range change? No. So therefore, it's still going to be x is greater than or equal to 0. And y is greater than or equal to 0. And we're still chilling at 0, 0. Okay, now let's look at the negative. How does the negative affect us? So we have negative 1/2. And we said that it's going to cause it to reflect over the y-axis. Boom. I'm like a bird. That's a song. I don't know that song. All right, so was our y values affected? No, just our what? Our x's. But so the domain of the x, reading from left to right, where do our x values start? Left. They're going forever to the left. What is that called? Negative infinity. So they go from negative infinity to 0. So our domain changed to this. Because of the reflection, our domain goes from negative infinity to 0, which means that x is less than or equal to 0 now.
Do you have to write the pair? Or can you just write?
No, the pair is just the way your set notation, your interval notation is just to help you make sure you do your inequality right. Our range is unchanged, and so are our y-intercept. All right, so here's the real test, putting it all together. So if you look at I, you have every single variable represented. Do you see that? Every single variable is represented. So based on that, I would like for you to take a moment and write out the transformations without graphing that you think took place without graphing. So without graphing, what transformations took place just looking at what you have? Yes, there's all variables represented, so there better be multiples. All right, so first you have your A variable, right? And A equals 3, because A equals 3, that is a vertical stretch. Okay, then we have our B variable. Our B equals 2, so that's a horizontal shrink. Yes? All right, this is where it gets tricky. What did y'all put for C?
Horizontal translation.
Okay. All right. All right, so this is the trick right here. If you go back, if you remember how we wrote our transformation rule, so for our transformation rule, it has to be a square root of b x minus c plus d. Is this in that format? No. So in order to know what your c really is, you have to divide out your b. So this is really 3 square root of 2x plus 1 minus 4. So your c actually equals 1, which means that it went -1, I'm sorry. So that means it went left. It's okay, I'll let you figure that, I'll let you go through that on your own on purpose. And then lastly, our D, and our D affects our Y lie, it's just -4. So it went down 4. So those are all 4 of the translations that took place. Okay, so that means when you're looking at this, your domain and your range have both been affected. Does that make sense? My domain now starts at -1 and continues to infinity. My range now starts at -4 and continues to infinity. So x has to be greater than or equal to -1, and y has to be greater than or equal to -4. And you can graph to verify.
So how did you know?
Because your C and D were changed. So when your C and your D are altered, it changes your domain and range automatically. Good question. Okay. All right, so just to recap the factoring thing, I just wanted to go over that with you again. Notice here how we have the square root of 9x minus 36. I know what my A is, but do I know what my C is? No. In order to find your C, you have to divide, B. You have to divide by the B value. So I have to divide by that 9 to know what my C actually is. And that's going to leave me with 9. And what's 36 divided by 9? 4. So now I can say that B equals 9 and C equals 4. Because B equals 9, that's a horizontal what? Shrink, the drop. And since C equals 4, that's a horizontal. We went which way? We went which way? Left or right?
Right.
Right. Went right. Okay. And because there's a C value, My domain is what? Changed. So my domain now starts where? At 4. So my domain now starts at 4 and continues to infinity. Is there a D value? No. So is my range changed? No. So range is still y is greater than or equal to 0. All right. That concludes attributes and transformations of square roots. Your exit ticket was your what? Your do now.